Okay, so we're going to talk about weather today and the things that affect weather. And this is chapter 7 in the book, or module 7, sorry. So, let's start by talking about the difference between weather and climate. How might you guys distinguish between weather and climate? Any idea? Could you distinguish? Do you think they're synonymous? They're mean the same thing? Do you think they're a little bit different?
I think they're different.
Mm-hmm.
I don't know how to say how they're different.
Well, how do we usually use weather? How do we use that word? When someone asks you about the weather, what do they mean?
What it feels like outside?
Yeah, so we're talking about like right now. Is it raining, right? Is it dry? Is it hot or cold? Is it humid? South Georgia, you were just in Hazelhurst, really humid down there. So yeah, weather has to do with what our experience is like as far as the weather goes right now, right? But now climate has to do with what the weather's like sort of in general in an area, okay? So like for example, we were just talking about in the last chapter that you're more likely to have an earthquake in California than you are here in Georgia. So I don't really want to live around that. But the weather that they have in Southern California is it's usually kind of nice, cool, kind of steady, the sunny and 70-degree sort of weather, like the perfect weather that we all love around here, where we have kind of more of a big fluctuation as far as the weather goes here. So in general, we would say in Southern California, that's what the climate's like, right? It's generally a nice, like around 70, 75 degrees, something like that. Maybe you tend to get a breeze because you're there on the coast in some of those areas like San Diego or something like that. But so climate is is like what the weather is typically like in a particular region. Okay, so let's just kind of define the difference between those two. Weather refers to the conditions of the Earth's atmosphere, right? That's where all this weather is taking place. In fact, we learned what part of the atmosphere this takes place in. Do you guys remember the name of the part of the atmosphere that weather occurs in? You almost said it. Nia almost said it. What were you going to say, Nia? Did you say troposphere?
But thermosphere?
Tropo was right, actually. So it's the troposphere. It's the lowest level, right? Which is inside the homosphere. So the lowest level of the homosphere. So refers to the conditions of the Earth's atmosphere at a given time. Whereas climate, in contrast to that, climate has to do with a steady condition that is prevalent in a particular region. So for example, we've been to Seattle a couple of times. And it's been absolutely beautiful. Both times we've been predominantly clear. You guys ever been to the Northwest, Seattle, like Washington State, Oregon area? You ever been out there?
I've been to Washington.
Have you? Okay. So what was the weather like when you were there? Do you remember? No? Okay. So there's a big mountain that you can see from Seattle. Do either of you know what the name of the mountain is? I mean, it's like really distinct and stands out because it's so tall compared to everything else around it. It's called Mount Rainier. And so on a clear day, you just have this beautiful view of Mount Rainier from Seattle. And so when we were there, most of the days that we were there, we were able to see this nice, gorgeous view of Mount Rainier. It was really pretty, very clear. It was totally unusual for the way Seattle normally is. Seattle is usually like cloudy and rainy most of the time. There's actually a rainforest out there because it rains so much in Washington State. And so the weather while we were there was clear and sunny, mostly, right? But the climate, what it's typically like in Seattle, is it's rainy and overcast, right? It's usually not very clear. So does that make sense, the difference in those two? Yeah. All right, so let's talk about the things that affect or influence weather. And there's kind of three main factors that influence weather. And number one, it's thermal energy. This is energy from the sun. And we've already discussed this some, when we discussed our atmosphere and the gases that are in our atmosphere, and we talked about like the greenhouse effect, things like that. So we've discussed thermal energy a little bit, right? The radiation that we get from the sun. Do you guys remember the dangerous type of light that comes from the sun that if God hadn't perfectly designed our atmosphere, we would not be able to survive because it would be deadly to us? You remember what kind of light it was? Ultraviolet, yeah. So we have this ozone layer that helps protect us from that. But thankfully the ozone layer is like not down here right on the surface, it's way up high. Why would it be bad if it's here on the surface? Just kind of testing you guys on like last chapter, a few chapters back, see if you still remember. Do you remember why it would be bad if ozone was right here?
Oxygen? Something about oxygen?
Well, it's poisonous. So we wouldn't want, it's in those tiny, you remember when we looked at the makeup of our atmosphere that's down close to us, that's here on ground level, it was what, 73%? Is that what it was? 70, how much was it nitrogen? I'm getting confused now. 78% nitrogen, right? And then like 21% oxygen, and then we had like 1% of these other things, and some of the other things were bad. We didn't need much of that stuff in there. Ozone was one of the things that was in that, like down here on the ground level. But thankfully, there is an ozone layer that's up way above us that is poisonous, so we wouldn't want there to be a lot of it here, but there's a lot of it up there to help protect us from UV light coming from the sun. So thermal energy is one of the things that influences the weather. Another thing is an uneven distribution of thermal energy. So not just the fact that we've got this energy coming from the sun, but the fact that there are things here on the surface and in the troposphere where these weather events occur, where the thermal energy varies. It's not the same all across the Earth. And so the fact that it's unevenly distributed across the Earth also affects the weather. And it's this portion here that has the greatest effect on the wind. How windy it is, where it's windy, those types of things. And then finally, the last thing that affects our weather is water vapor in the atmosphere. And so that can manifest itself either as humidity or clouds. Clouds would be included in that, right? That's part of our, when we talk about weather, clouds is a part of that. Is it going to be cloudy today or sunny today? So I'm going to talk about clouds first. So our experiment today is we're going to try to make a cloud, make clouds in a bottle. All right? I've never tried this experiment, and I'm going to like totally just let you guys do it. I'm going to step back and watch and see what happens. But if you guys cause a thunderstorm in my house, I'm going to be upset. All right? So there was an earthquake, Natalie. So she's going to be watching this later. It's like, what happened? All right, so any questions about this? About what these different things mean? Is that clear?
Yeah.
Yeah, we got it? All right. All right, so let's talk about clouds, specifically what the different types of clouds are that we see in the sky. I'm sure you've noticed that clouds don't always look the same, right? Let's see if I can move this a little bit, actually, so maybe you won't accidentally bump it again. Be out of your way. Let's see, how do I twist that? Is it this? No, that does that. I want to do this, I think. There we go. Okay, so what are the different types of clouds? Anybody off the top of your head know how many different types of cloud classifications there are? Big categories? Do you think you know? A lot? Well, there's actually only 4, but there'll be like mixtures of these 4, so we come up with a lot more because of that. But there's 4 big categories that we're going to talk about.
I was going to say a lot.
What did you say?
I was going to say I forgot what.
Oh, you remember some of the names. I'm sorry, I thought you said a lot. So you don't remember like one off the top of your head though?
I remember was cumulus.
Yeah, cumulus. So there's cumulus, that's actually the first one we're going to talk about. So 4 categories. And the first one is the cumulus clouds. These are my favorite. They're all really cool. I mean, to me, clouds are just one of the coolest inventions of God, right? When you look out and I see what the Lord's put in the sky as far as the way clouds look at different times, it's just, I couldn't imagine not having clouds in the sky sometimes, just how neat they look. And it's like the Lord just paints this masterpiece across the sky at different times, and then when the sun's reflecting off of it in different ways, it's just really cool. But this is from the Latin word meaning, since that's kind of a weird term, cumulus, it's Latin, it's based on a Latin word, it means a pile, and it looks like a fluffy pile of cotton. All right, so there's actually a picture in your book, if you go to this page 158. So we've got the four basic types on page 158 if you want to check that out. And I want you to be able to recognize these based on the way that they look, okay? So make sure you know how to do that for the test that you're going to take. If I showed you a picture, you should be able to pick out what type of cloud it is based on the picture, all right? So the cumulus definitely looks different from everything else, right? It definitely has that fluffy, piled up look compared to the other ones that are sort of spread out. Some of them kind of wispy. It's more like sort of clumped together or steady across the sky, but this is just like piles of cottony fluff. Our experiment is going to, we're going to do that after we talk about the cloud formations, but the experiment's going to be like the cumulus clouds form. It's that kind of idea. So we're going to try to create some mini cumulus clouds if we can. If you add, I want to make sure you understand this. If add alto to the name, then that means that it is found at higher altitudes than usual. So if add alto to name means at higher altitudes than usual. So this is one of those ways that I was saying we can get variations of the cloud names, right? We could say a cumulus cloud because we see one and it's just where you normally expect it and it's got that nice fluffy look and it's very clearly cumulus. Or we could call it an alto cumulus cloud. So if we stick alto on the front, it means that's a cumulus cloud, but it's a lot higher in the atmosphere than we would normally expect cumulus clouds to be, right? Another prefix that we might put on there is the prefix nimbo. So if add nimbo to front or nimbus, that's what we hear more often, or nimbus to the end, it means it's usually a rain cloud. So if you've ever heard the term a thundercloud, that's a thundercloud. We're typically talking about cumulonimbus clouds. It's a cumulus cloud that's a rain cloud. It's turned dark. So we just add nimbus to the end to identify it as a rain cloud. And just talk about how cool clouds are. Like these cumulonimbus clouds are sometimes so tall that they'll stretch. Remember, this all is happening in the troposphere for the most part, but they'll stretch like from just a few thousand feet above the ground to like the very top of the troposphere. So we're talking like clouds that are 6 to 7 miles tall, massive cloud structures. So that's the cumulus cloud. You guys think you could pick that one out? Based on the picture there? Think those are obvious enough? To me, those are like some of the easiest ones to identify, right? All right, I'm going to write the name of the next one. This is a cirrus cloud. From Latin meaning wisp or curl. And these are, if you look at the picture, the name should make sense. These are wispy, thin clouds made of tiny ice crystals. And they have a feathery appearance. So that's that's one of the ways you can identify those. They're at the top of the troposphere. And are thinned out due to high winds there. All right. You guys finish writing that down. So again, looking at the picture on page 158, those clouds are also pretty distinct, right? You can see this idea of how the high winds like spread them out. They're always kind of thin and got that feathery appearance on the edge there. Kind of makes me think of cotton candy when you pull it apart, you know, the way that it looks on the edges. So that would be the cirrus cloud. The next one that we want to talk about is our stratus clouds. Stratus, and you can see a picture of that. 7.1C is the stratus clouds. They're usually low in sky, and when these things form, it's when there's a mass of warm air is lifted upwards, so that's what generates the clouds. But they form a flat layer of clouds close to ground, and can easily become nimbostratus clouds. So what do I mean by that? What would a nimbostratus cloud be?
Would it also be a rain cloud?
Yeah, it's just a rain cloud, right? So nimbo always means that it turns into a rain cloud. So can easily become nimbostratus clouds. We put the word at the beginning when we're talking about stratus clouds, so turn dark and produce rain. That's what we mean by that. All right, now I'm going to go ahead and just put the last one, which we don't see very often here because these are generally found in mountainous regions. This is the lenticular cloud, usually in mountainous regions, where I have pockets of low pressure and the name means lens shaped. Because usually form an oval. And so just take a look real quick before you finish writing down. If you look at 7.1D, that's the only one of the four clouds that we're looking at that's clearly got that circular shape to it, that oval shape, right? So that really is what makes these stand out from the rest. The lenticular are easy to spot because of that spiraling circular shape that they have. So these are nice, 4 big categories. Would be great if it was always that distinct, so it'd be easy for us to go, oh, that's a cumulus cloud, or that's a stratus cloud. There's kind of like an example that I heard last night from where a pastor was talking about the meaning of words, like just in general, and words aren't always so clear and cut and dried as we'd like them to be. He was talking about a word like knowledge and understanding and wisdom. You know, we want to sometimes think about them as clearly distinct from one another, but a lot of times there's overlap, and one may carry a slightly different meaning, but in some cases it can mean exactly the same thing. And he compared it to like a river flowing into an ocean, and as the river gets close to the ocean there, it's like where there's no hard line where the fresh water ends and the salt water begins, right? It just kind of gets mixed together. And so you have that with clouds, actually. Like you don't have nice, distinct categories a lot of times. Like you might have, for example, cirrocumulus clouds. What do you think those might look like?
Maybe a mixture of cirrus and cumulus.
Yeah, they're like aspects of both, right? So they're made of, cirrocumulus clouds are usually made of tiny ice crystals the way that the cirrus ones are. And so they'll get feathery on the edge, but they're not blown apart the way that cirrus clouds are. They pile up the way cumulus clouds do. And so like you get these kind of wispy piles of clouds, and it's really because this is just a combination of the two, right? Here's another one that we see. We see stratocumulus. So that's obviously a mixture of stratus clouds and cumulus clouds. And so these are fluffy clouds that are, what do we find? What's one of the key distinguishing characteristics of stratus clouds? They're very low in the sky, right? So we get these fluffy clouds that are really low in the sky. They're stratocumulus. And then cirrostratus. Those clouds, unlike stratus clouds usually are, that are low in the sky, they've got characteristics of stratus clouds, but they're high in the sky, and they're feathery, but they form a flat layer the way that stratus clouds do. And we didn't really talk about the stratus clouds as far as looking at that picture. I didn't focus on that. But if you look at 7.1c, do you see how they're just really, you got this kind of low, flat, sort of long cloud. Not all the bumps and everything like you have in some of the other clouds. So that's a characteristic of stratus. So you may have mixtures of these. Sometimes if you're looking at the sky and you're trying to nail one down and say which of the 4 is it, right? Because I know you guys are gonna be driving home now and going, what kind of cloud is that? You're gonna be thinking about your categories, but it might not fit in those nice 4 categories. You might have to combine some together to sort of describe the clouds that you're seeing today. All right. So any questions about, let's see, is there I've got a note here to look at 7.2, so let's see what 7.2 is. Oh, okay. So yeah, there's a drawing on page 160, figure 7.2 that has a summary of all the different, not only the individual ones, but some combinations of them. So there's the cumulonimbus, those really tall clouds that I was talking about, that are rain clouds, that get so big and can stretch for 6 or 7 miles high. Nimbostratus, that's a flat, right, cloud that's low to the ground, but it's dark and producing rain. Stratocumulus, that's stratus clouds, but they clump up the way cumulus clouds do. Lenticular is the only one that we don't really see combined together with any of the other ones. And again, what's the distinguishing characteristic of a lenticular cloud?
It's shaped like an oval.
Shaped like an oval, and we find them where usually? Do you guys remember that? Usually in mountainous regions, right? So they're not. That's not the kind of cloud that we see around here. Typically, you've got to have some changes in the land and the topography of the land beneath it, so that you'll get these pockets of low pressure that produce those types of clouds. And then the cirrus clouds are those wispy ones at the top. You can kind of see through those compared to other ones because they're made out of those little ice crystals, and they're up high where there's high winds, and they sort of get blown apart, right? Got that feathery appearance to them. All right, so you guys think you could recognize the clouds if I gave you a picture of them? So here's a huge hint. All right, your next test has 3 pictures of clouds on it. All right, it's not really a hint. I'm just telling you what's there. So you got to be able to recognize the clouds by the picture. All right, so make sure that you can identify those based on the picture. All right, now we want to see if you guys can make some clouds, all right? So we're actually going to go back. We did not do an experiment back in. There's only one experiment in this particular chapter here, and it's an experiment that spans like multiple weeks. And since we're on a very short time frame, we really need like 4 weeks to do this experiment, and we're not going to have time to do that. So what we're going to do is go back and do an experiment that we skipped, that was a couple of modules back, where we try to create clouds inside of a 2-liter bottle. Okay, so that's experiment. I think it's 5.3. It's on page 122. So I want to let you read through that. And like I said, you guys are totally in charge of the experiment this time. I'm going to be hands off. You're gonna do it all. All I'm gonna do is just put my goggles on so that you guys don't try blind me. Okay, so you can get whichever goggles you want there. Wouldn't it be super cool if we could actually create clouds and a little thunderstorm developed in the jar? That would be really neat, right? A little like self-contained thunderstorm. That would be awesome. All right, so let's go ahead and read through that. Just make sure that you know what you're going to do. It's not a very long experiment. And then I'll let you fill it up. I'm going to pause this or stop it.